We at BASF understand the needs of our partners. We realize that the world is changing fast.
That opportunities abound and that business is ever more challenging.
We see these challenges as opportunities.
BASF offers more than just products.
We develop intelligent solutions and work closely with our customers to make them even more successful.
As the world's leading chemical company, we are aware of our responsibility.
We at BASF are helping to shape the future.
Up to 2,004 truck manufacturers have succeeded in fulfilling emission regulations by advancements in engine components and sophisticated engine calibration. To meet the emission standard of the future, starting with the introduction of Euro 4 and US 07, all manufacturers are using exhaust after-treatment technologies, in addition to engine calibration, to reduce the emissions of their vehicles. The harmful gases produced by the heavy-duty diesel engines are purified in the exhaust after-treatment system, consisting of a diesel particulate filter for the soot particles and a selective catalytic reduction catalyst, also called SCR, for the nitrogen oxides. BASF engineers are working jointly with their customers at the truck manufacturers to improve the performance of the whole exhaust after-treatment system by providing the latest catalyst coating technologies as an active interface between substrate and exhaust gas. Truck manufacturers have accomplished the reduction of raw emissions, mainly by increasing the diesel injection pressure and turbocharging. In addition, they have managed to reduce nitrogen oxide emissions by applying exhaust gas recirculation to cool the combustion process. For Euro 4, the majority of heavy-duty truck builders have chosen selective catalytic reduction by AdBlue. SCR technology allows for the optimization of fuel economy while meeting particulate emissions via engine control without a filter. To meet the even tighter Euro 5 standards, the same engine calibration is desired with an improvement of catalyst performance of 10 to 15% in nitrogen oxide control. This is a typical challenge for BASF engineers and could be accomplished by the introduction of new improved SCR emission technology. Euro 5 compliant trucks with BASF SCR technology are available on the market now. In the U.S., truck manufacturers have chosen a different way to meet tighter regulations, coming into force at the beginning of 2007. All of them have chosen to control nitrogen oxide by engine management and will use diesel particulate filters to control soot emissions. The continuous regeneration of the filter is enhanced by a catalytically active coating provided by BASF for such application. This is known as a CSF, or catalytic soot filter. In addition, active regeneration of the filter is required to force periodic particulate burning at temperatures above 600 degrees Celsius. Only 3 years after the introduction of the US 07 regulation, the US 10 emission standards will come into force, challenging the truck manufacturers to reduce nitrogen oxide emissions by a further 80%. BASF already has the equivalent emission technologies in place. In this example, by combining the catalyzed soot filter with the SCR nitrogen oxide reduction technology. Ideally, many truck manufacturers would like to carry over as much of the US 07 emission after-treatment technologies into the US 10 solution by adding the SCR technology as nitrogen oxide control to the US 07 emission system. Let us now investigate what will happen with the emissions of an advanced diesel engine in such a future exhaust after-treatment system and start with the catalyzed soot filter. The catalytically active material is coated on the ceramic substrate in a specifically developed process for wall flow-through filters. 2 channels are shown as an example to show the processes in the filter. During the highway and long-distance duty cycle, the temperatures in the filter will be between 300 degrees and 450 degrees Celsius. First, we show the soot buildup, starting with the rear section, and then we show the layer of soot on the channel walls. Under these driving conditions, nitrogen oxide, NO, is formed. NO reacts with oxygen in the exhaust gas. The blue flashes show the reaction. This reaction, NO going to NO2, takes place only in the presence of a catalyst. NO2 is a very reactive gas. It is able to reduce the accumulation of soot or even to burn off the soot, as shown by the red flashes. The catalyst can oxidize NO, which arises as an intermediate product during the soot burn-off, back to NO2. A circular process takes place that increases the rate of soot burn-off in the catalyzed filter. In contrast to highway driving, city driving requires special engine operation in order to produce temperatures of 600 degrees Celsius, which are required for the soot burn-off. Assume that a layer of soot is already present as the result of previous driving. During city driving, this soot cannot be removed under normal operation by reaction with nitrogen dioxide. Diesel fuel is injected after the turbocharger into the exhaust pipe and burnt to raise the exhaust temperature of 600 degrees Celsius and above. The soot reaches the ignition temperature and burns off. The combustion leads, as usual, to carbon dioxide. Carbon monoxide, which forms as an intermediate product, is catalytically oxidized, with the heat of reaction promoting the soot burn-off. In this manner, the filter can be completely regenerated. Now that 95% of the soot particulates are removed, the emission gas still contains considerable levels of nitrogen oxides, which will be removed in the following SCR system. The SCR system consists of the separate AdBlue tank, easily recognizable by the blue tank cap, the AdBlue dosing unit, and the downstream SCR catalyst. Soon after the filter, AdBlue by BASF, a highly pure solution, is injected into the exhaust system. The amount injected is mainly dependent on the speed and load of the engine. The temperature of the exhaust gas converts AdBlue by BASF into ammonia that will remove the nitrogen oxides in the following SCR catalyst. Depending on the amount of NO2 provided by the upstream catalyzed soot filter, the following two reactions take place in the SCR catalyst. Nitrogen oxide and ammonia react in equal amount to water and elementary nitrogen, a natural ingredient of the air we breathe. The reaction is relatively slow, and thus at temperatures around 200 degrees Celsius, conversion rates are low. The so-called fast SCR reaction is at temperatures of 200 degrees Celsius 10 times quicker than the first reaction, but only takes place when nitrogen oxide and nitrogen dioxide are present in equal amounts on the SCR catalyst. In this case, they react with the same amount of ammonia to elementary nitrogen and water. The nitrogen oxide rate at the engine outlet is relatively low, typically 5 to 10%. However, the upstream catalyzed soot filter has produced sufficient nitrogen dioxide to enable the fast SCR reactions. BASF offers an application engineering service to the truck manufacturer to adopt the catalyst technologies to the customer emission systems in a way that the right amount of excess nitrogen dioxide after the catalyzed soot filter is produced to enhance the fast SCR reaction on the SCR catalyst in as many as possible engine speed and load points. With the new high-temperature stable non-vanadium SCR technologies from BASF, truck manufacturers can carry over US 07 filter regeneration strategies without significant further modification and are able to place the SCR converter behind the filter because the second generation of SCR technologies can withstand temperatures in excess of 700 degrees Celsius. After the SCR catalyst, up to 95% of the nitrogen oxide emissions are reduced to elementary nitrogen and water. Due to the ever-changing speed and load points, control of AdBlue dosage is very complex, and it may occur that too much ammonia is exposed to the SCR catalyst and leave the SCR catalyst. A small ammonia oxidation catalyst added to the end of the SCR catalyst offers two significant advantages to the truck manufacturers. Firstly, excess ammonia is securely converted to elementary nitrogen and water. Secondly, it allows the engineers to have more freedom in the urea dosing control and thus achieve more NOx reduction performance out of the SCR system, which in turn can be used to reduce the size of the SCR catalyst. BASF emission technologies for heavy-duty vehicles make a decisive contribution to the continued maintenance of air quality. Together with our customers and partners in the automobile industry, we make sure through innovative products that future emission standards will be met. BASF, the chemical company.